So coming to the ncert examples, the first question you can see here, already I have taught you. So the first question itself is the note. So what is note? Note is a sound of they are asking. So what is a note is everybody? Note is a mixture of several frequencies. Note is a mixture of two frequencies only. Note is a mixture of single frequency, always unpleasant to listen. So mixed frequencies we used to call something and single frequency we used to call something. Both I have taught you during teaching the quality. So everybody verify it and let me know. Everyone, what is that everybody? Yes, please. While you are studying the quality, we have studied that I want what is not. Your NCERT book also it is there. Anybody?
The single frequency is known as tone,
Yeah.
sir.
Produce a single frequency. So that is what we used to call it as note. Is it? A musical instrument produces a sound of several frequencies, which is call it as a note. Or
Yes, sir.
yeah. So what is that call it as? Single frequencies. What we used to call?
Tone, sir. Tone.
Yeah. A sound of a single frequency is call it as a sound of a single frequency, which is to call it as a what? Everybody. It is the
Tone, sir.
tone. And a mixture of several frequencies, which is like a musical instrument. What is to call?
Note.
Yes, note. That is what. So what is the correct option? Option A or C? Option
A.
A. Your NCERT book also it is there. Immediately find it and tell me the page number. I am having old book. I cannot find. You have to tell me. Make it fast. Let me see who will find it first. It is there somewhere, Mari, regarding amplitude, loudness, pitch, frequency. When there's paying there, it will be there. Quality. Just verify and let me know. So, everybody speed up, search fastly. Kariya, Adi. If you are not able to search in the book,
132.
yes, Amma. Who is that?
132.
132 somewhere. Just find it, guys. She is saying correct. NCRT is our main priority. We are entering into the board exam next year, and people are saying full portion in exam, full portions exams in December once, and again you will get a second chance for like better performance in again January last of February it is. So things are not easy. So you should understand it. So people are in a hurry to complete the syllabus. By August, September is a maximum target to complete the syllabus. So then imagine how fast you have to be there. It's a just not confirmation, but people are saying by full portion only, most probably. So and if you are like this, then imagine. Where it is there, Amma, page number 130,
132.
132. So 132, yeah. So here it will be there. Yes, even the intensity and loudness also here only there. You can see that. So in the interchangeably, but they do not same. Loudness is a measure of the response of the ear to the sound. Even when two sounds are of equal intensity, we may hear one as louder than the other simply because of your ear deterioration. But where it is there? Note. Yes, here. We have here. A single frequency is called as a what? Everybody? A single
Tone.
frequency is called as tone and note. Where is notra? Now they are asking. No, they are asking what now? Tona, nota. This is note correct. Yeah. So note only. So correct only. So where is the note? Note is not there. Yes. Why is there or not there? Next line itself. The sound which is produced due to a mixture of several frequencies is called as a note and it is pleasant to listen. Like that is what we can say is our musical instruments like guitar, sitar and all, multiple strings will be there. They will produce multiple frequencies. That is what we used to call it as note. Understanding? So tone and note. So first question, instead of note,
Note, sir.
no. First question, instead of note, they will put tone. What is the answer? Option C. If the instead of tone, they will put note. What is the answer? Option
A.
A. So please remember that. Clear, everybody? All of you?
Yes, sir.
Yes. So that is what.
Yes, sir.
Please remember, tone means single frequency. Note means several frequencies produced by a musical devices. That is what is the difference between them. That's what you have to work it. Next, a key of a mechanical piano struck gently and then struck again, but much harder this time. So in the second case, what will happen? It is stucking too much. So what will happen, everybody? The sound will be louder, but pitch will not be different. Sound will be louder and pitch will also be higher. Sound will be louder, but pitch will be lower. Both loudness and pitch will remain unaffected, they're asking. So a key of a mechanical piano struck gently and then struck again, but much harder this time. So much harder this time means what will increases, everybody? The number of frequencies are same, but what will happen? Harder, the depth is increases. So what will increases? Everybody? Yes,
Frequency increase.
frequencies increases, not
Sir,
much.
actually, in the frequency, the amplitude increases.
Yeah, amplitude, the same frequency it will be, but what increases? Before, imagine this is the amplitude. Now the amplitude rises, but the frequency remains what? Frequency remains same. Amplitude alone changes. So amplitude changes means what will happen? Amplitude
Loud.
changes means it will be
Loudness increases.
louder sound. So louder, but pitch will not be. Frequency remains same. So pitch will not be. Pitch will not be. Frequency remains same. So pitch is remains same or different? Pitch is remains.
Remain same.
So
Same.
that is what we have to remember. So sound will be louder, but pitch will not be different. The depth, the key pressing you see, you have to press lightly. Lightly means what? From the main position, it is going up and down. So if it is more harder, it is stuck so that it will go very deeper inside. So what will happen? The amplitude increases. Amplitude increases means sound will become what? More louder or softer?
More loud.
Louder. So louder means, so the frequency remains same. So pitches remain same, but loudness increases. Loudness increases because amplitude increases. Clear, everybody? Yes? Yeah. So next question, read. Next question I already taught you. So what is this? In a sonar, what is the full form of sonar, everybody? Full form of sonar. Sonar. We already studied, correct? Sonar.
Sound navigation and ranging.
Yes. Sonar is used by Indian Navy, submarines and all we have seen for finding the depth of a ocean and all. We already studied it. Is it right, everybody? Yes or no? Sound navigation
Yes, sir.
and sound navigation and
Ranging.
Ranging.
So we use what actually? Ultrasonic waves, infrasonic waves, radio waves, and audible sound waves. Which is
Ultrasonic waves.
Ultrasonic waves.
ultrasonic waves. What is the reason behind ultrasonic waves? Because ultrasonic waves cannot be heard by us, so that it will not be affect the sound of a ship and all. That's the reason we are using what waves? Ultrasonic waves. And also another reason what? They will penetrate very deeper inside, even through the obstacles also. Is it right or wrong? Everybody?
Yes, sir.
Yes. Now, sound travels in air if what? All of you read one after one and make it fast. Sound travel in what?
Disturbance moves.
Yeah. So, and what is a wave? Anybody? Sound waves are what waves? Longitudinal waves or transverse waves?
Longitudinal.
Longitudinal waves. Very good. Next.
So one doubt, sir.
Yes, Mar.
which can be called as transversal waves, sir.
Transversal waves are mechanical, like we can say it's like a thread rope disturbance, this, that, and all. Okay?
Yes, sir.
Yeah. Next. All of you read. What is that? I want answer. What is the answer for this question?
Frequency.
Yes?
A.
Yeah. What is the answer? What they're saying? Sound travels in air if particles of medium travel from one place to another place. Particles of medium, they will travel, or only they will make the displacement from the mean position. They'll make the displacement from mean position. So they will never
Only the
travel.
disturbance
Yes,
travels.
they will never travel. They will just make a displacement from the mean position. To and from motion, they will make it. So that is what you have to remember. Next, what will happen? So first one is not there. Fourth one. Second one, there is no moisture in the atmosphere. Is it moisture matters? Moisture does not matter. But speed of a sound is depends on some other thing. Anybody can tell? Speed of a sound is depends on another thing. Sanjay, I want response.
Temperature.
Temperature. So temperature of a medium will affect the speed. That is also clearly mentioned in the place of echo. And I also taught you. So that's the reason we are having air. We are having three different temperatures at 0 degrees Celsius, one temperature, at 22 degrees Celsius, another temperature,
And
and
25 degrees
25
Celsius.
degrees Celsius, we are having another temperature. And clearly in the place of echo, they mention echo distance. What is the minimum distance to hear the echo? Everybody, 17.2 meters.
10 meters.
But this distance will change with the temperature of air. For assertion and reason, very, very important question it is. So the echoes may be heard more than once due to successive or multiple reflections. That is what makes the thundering ring. The rolling of thundering is due to the successive reflections of the sound from a number of reflecting surfaces such as the clouds and the land. How the sound will produce during the this thundering and lightning. That is what you have to remember. Clear, everybody? Yes, please. Understand, Amma?
Yes, sir.
That is what you have to remember it. Make it fast. Everyone, see, that's a book reading is very, very important. How you are reading the book is always a matters, and every word is important in the book. Keep it in mind and do that. Next question. When we change feeble sound to loud sound, we increase its what? Louder. Feeble means very soft. And what is another word, Sanjay? Fainter, am I right? Fainter, yes. So faint sound, so feeble sound. So now what we have to increase us? Everybody? Louder sound. So louder sound means what we have to increase? Everybody. Mr. Jayan, good morning.
Amplitude.
Amplitude. So that is what it is. Loudness increases means amplitude increases. That is next. If the curve, half the wavelength is, they're asking. So can you tell me? In the curve, half the wavelength. I already taught you. So half the wavelength means from where to where we can say. Anybody?
B, sir.
Yes, please. Half the wavelength. Half the
Sir,
wavelength means, while teaching time also I have taught you. So you all knows that from the one crust to immediate trough, the distance between the one crust to the immediate trough is what? Lambda or lambda by 2? Everybody.
Lambda.
Lambda by 2.
by 2, sir.
Next crust. From here to the next crust, we used to call it as again lambda by 2.
Lambda.
Am I right or wrong? So then distance between the crust and crust, what we used to call? Successive crust and crust. We used to call it as wavelength. Is it right or wrong? Lambda. So that is what? Lambda by 2 plus lambda by 2, which is equals to 2 lambda by 2. So 2 will get cancelled, lambda will come. Now they are asking half the wavelength. See, that is a good question or not? So half the wavelength means what? B and as well as
BD.
D. So that is what is the half the wavelength. So lambda by 2. Half the wavelength means lambda by 2. So what is the answer? BD. Very good
B
question. This question, everybody, draw it and do it. Make it fast. All of you should do it. Mr. Prudhvi late. Mr. Zayan, good morning. No sincerity, Zayan. Nothing is doing. DRD, I think 4 mark or 3 mark, I think. Make it quick, everybody. Completed. Padma doing a.
Yes, sir.
Do it fast, everybody. Any doubt? Anybody can ask me. Completed, all of you?
Yes.
Next. All of you answer this. Earthquake produces which kind of sound before the main shock wave begins? Before main shock wave begins. I already taught you this also. Only animals can listen, like elephants,
Infrasound.
dogs, and all. Yes, please. Which we cannot hear. Anybody? If you're
Ultrasound.
talking, yes, infrasonic sound, so that we cannot hear. Only who can hear? Certain animals, yes, certain animals like elephants, they can hear these sounds. That's why they will show some reaction towards to that before us. Is it right or wrong? Everybody?
Yes,
Yes,
sir.
that is what. Infrasonic sounds. Next, infrasounds can heard by what animals? I have given you the examples.
The
Infrasonic
rhinoceros.
sounds can be heard by rhinoceros.
Yes.
Rhinoceros. Next, before playing
Bat.
the before playing the orchestra in a musical concert, sitarist tries to adjust the tension and plug the string suitably. By doing so, he is adjusting the what? Intensity of sound only, amplitude of sound only, frequency of the sitar strings with the frequency of the other musical instruments, loudness of the sound. What he is doing? They will adjust the
Option
tune.
C.
Yes. So they are adjusting the what? Musical frequencies, because all other pitches should be matching, not here loudness. So the before starting any kind of singing or anything, all the persons, all the different varieties of musical instruments, they will adjust their strength. That is what tension in the string we used to say. So what is the reason behind that adjusting the frequencies, so that the vibrations will vary. So number of vibrations will changes, the tightness. So that is what we used to say is frequencies. So they are adjusting the frequencies with other frequencies of the other musical instrument, so that the what we can say is uniformity will come. That is the reason they will make it. So all of you make it fast. Anybody having doubt, you can ask me till here. In this, the most important question is sixth question. Sixth question is a very good question. You have to know it. While teaching them also I have taught you. Next, 10th question. 1 minute time. Everybody start doing and then I will teach you. Everybody need to do. Whomever I ask, you have to answer me now. Make it quick. Very simple question. Just it's a what is a graph? Everybody, graph observe displacement versus
Time.
displacement versus time graph. Just you have to do it. It is what? Microseconds. What is the time here? What is the time here? Microseconds. Understanding? So microseconds, I will teach you now. So please learn this one. Sanjay, recently you shared something to me, correct? That I will share with them. So there is a unit terms and all. You can notice it. 10 power 3, 10 power now micro, correct? Micro, it is there. It is not there. Okay, I'll teach. So remember everybody. Normally we all knows that 1 meter is equals to 100 centimeter. Same way, 1 meter is equals to 1000 millimeters. Same way, 1 meter is equals to 10 lakh. 10 lakh micrometers. Same way here. Microseconds also. Prima, எல்லாமே understand? 1 minute is equals to 60 seconds, correct? Same way, 1 second is equals to milliseconds and nanoseconds. Please remember. 1 second is equals to 100 milliseconds. Same way, microseconds. Microseconds means 10 power minus 6. So write that value I want to make. Okay. 10 power minus 6. Okay, seconds is equals to 1 microsecond. Clear? 1 second is equals to 10 power 6 microseconds. Reverse now. 1 microsecond is equals to how much, everybody? 10 power minus 6 seconds. Purima, understand, Ra? Please respond, everybody. So 1 microsecond is equals
Yes,
to
sir.
how many seconds now? 1 microsecond is equals to 10 power minus 6 seconds. Understand, guys? Yes, that's what it is. Now, so the given graph shows the displacement versus time relation for a disturbance traveling with a velocity of 1500 meter per second. What is the velocity? Capital V. Velocity is equals to how much, everybody? 1500 meter per second. Next, calculate the wavelength they are asking. So if you want to calculate the wavelength, now Hasini will say the formula, or Mukesh Kalyan. Can you tell me wavelength and velocity formula?
Velocity equal distance traveled by time taken, sir.
Velocity is equals to distance travel. I am asking according to sound, Mr. Mukesh. You cannot say me normal formula. Do you understand? I am asking velocity from here, sound chapter velocity, and I am not asking distance, wavelength they are asking. You don't know the relation? That's what I am asking. Alpha
Sir,
lake.
frequency.
What is the formula? Velocity is equals to, we have studied. Hasini, I asked you, don't listen me. Velocity is equals to, what is the formula, guys? Two formulas we
The
have.
lambda into
Yeah, one
frequency.
is wavelength divided by time period.
Time.
Second one is what? Or
Lambda into frequency.
wavelength into frequency. But here we are having what now? Time versus displacement. So what we can use it?
Time.
Yes, please. What we can use it? First formula. Am I right or wrong? That is
Yes,
what.
sir.
So starts with the distance between the two successive crusts. That is what wavelength. So we don't know how much it is. So I am taking this is. Any problem for anybody?
No, sir.
That is only correct wavelength means. Yes, all of you.
Yes.
So that's what. So wavelength starting from 1 second. You can start from anywhere. 1 second and ending from 3 seconds. So can you tell me what is the time period? What is the time period?
2
What
seconds.
is it? 2 seconds or 2 microseconds, Amare?
2 microseconds, sir.
2 microseconds means in the sense of 2 into 10 power minus 6 seconds. Will you all agree with me? I want response from everybody.
Yes, sir.
Yes, all of you?
Yes.
That's
Yes,
all.
sir.
Now displacement. We all knows velocity, we knows, and we know time. We cannot find the wavelength. Easily we can find. So what is the wavelength formula? Wavelength is equals to velocity into time period. Is it right or wrong? Everybody? Yes?
Yes, sir.
Yes. So velocity is 1500 meter per second. Time period is
Sir,
2
one doubt,
into
sir.
10 power minus 6 seconds. 1 minute. Second will get cancelled. Yeah, tell me, Mari.
Sir, are we assuming that that is two microsecond as the time?
I am not assuming one wave is taking, that is what is the time period, correct? Time taken to complete one wave is called it as time period. Do you understand?
Yes, sir.
You take anywhere, Mari. You don't worry about my point. You take from anywhere. Where you want to
Yes.
starting from the wave. So let me take, see, it is starting. Let me take here. Is it okay? Wa? Understand now? Now 0,
Yes.
here definitely what will be there? 0.5. Is it okay? Wa?
Yes, sir.
Then here what is that? 2.5. Now 2.5 minus 0.5. How much, Mari? 2.5 minus 0.5, which is equals to 2 only. Yeah?
Yes, sir.
Do you understand?
Yes, sir.
Anywhere your choice, but it is easy to calculate between the crust to crust. That is what is our wavelength. Generally, we'll take between the crust to crust, correct? So crust ends by 3 seconds, 3 microseconds. Crust started by 1 microsecond. So 3 minus 2, it is equals to 2 microseconds. That's all.
Yes, sir.
Am I right?
Yes, sir.
Everybody? Amma, understand, Amma, others? Agalya, Shivani, Kavya?
Yes.
Yeah.
Yes,
So
sir.
what is the answer now? 1500 into 10 power 2 into minus 6. So 15 twos are 30. 30 into, here two zeros are there, so I can reduce it. So what is the answer? Anybody? 10 power minus 4. Is it right? Yes? Or else I can say like this. You can see, don't worry about it. So I can write it. 15 twos are 30, double zero is there, into 10 power minus 6 meters. So 3000 means, can I write as a 3 into 10 power 3? Any problem for anybody? Any problem? Mr. Mukesh doing so which is equals to 3 into 10 power 3 minus 6, 10 power minus 3 meters. That is the wavelength. Any doubt anybody can ask me? Very, very important sum. Solve it neatly. You have to solve. Prince, you cannot able to see the screen. Network problem. You can verify.
Sir,
Yes.
Sir, I got the answer as 30 into 10 power minus 4, sir.
Okay, man.
Meter.
But final answer always you have to make it into single digit. That's what I say. So, you can make it.
Yes.
Yeah. Do it fast, everybody. Prithvi is solving Mr.
Yes,
Sam,
sir.
nothing doing, Sam. Everything diverted. I'm saying you. No dedication, nothing. Do it fast, everybody. Very important this question. Any doubt, ask me. Girls, solving
Yes, sir.
I'll fin
Yes,
20 minutes late. Very sincere. Make it fast, everybody. Mr. Nivedan, Gokul. Very simple. You can assume
Yes, sir.
anywhere. Anywhere you can assume. Assume the wavelength. What is the wavelength definition? Distance between the two successive crusts. Is it right or wrong? First definition, that only for us. So you assume that and you take the time, and they have given in microseconds. So learn it, please. Microseconds means 1 microsecond is 10 power minus 6. So make it everybody. Sam, everything connecting issues and all from 1 year almost. You have to rectify everything. Inform mother or father, make it everything perfect. Don't say me these stories and all, Sam. Next question. Completed this question, everybody? Agale done now?
Yes, sir.
Next solve. Which of the above two graphs, A and B, representing the human voice is likely to be a male voice? Give reasons for your answer. Male voice and female voice. Male voice, what is having? Female voice, what is having? You all people knows. Anybody?
Flat pitch and
Sir,
shape.
shrill, sir, shrill.
Yeah. So the
Female.
female voice, please note it. Female voice is having high frequency. Frequency is high. Male voice, loudness is high. So means in the sense of amplitude. Amplitude is high. For them, pitch is high. For us, loudness is high. So now you all of you observe and you tell me. So this is the first graph. Let me take it. This is the first graph, and that is the second graph. So now just you can make it and tell me. First graph, you see that frequency is lesser, more. Orange graph. Orange graph, verify and tell me. Yes, please.
Frequency is less.
Yes. That is what you have to remember. Clear, everybody?
Sir,
Yes.
for male voice, loudness will be greater as well.
Yeah, loudness will be higher.
Amplitude.
Yeah, amplitude is greater. That's what. So first graph. First graph, low frequency or high frequency. That's what I wanted. Low frequency or high frequency? First graph, A, this orange color graph. Low frequency. Do you understand? So man voice is having low pitch and female
High
voice is
amplitude.
having high pitch. So a graph A is a what voice? Man or man's or a woman? It is a man's voice. And this one, dotted one, is a what? Yes, please.
Women's
Female voice, woman's voice. Woman's voice. So what is the reason? First answer is what? You have to write it. So when we see the frequency of a graph A, right, it is less or more. Frequency of a graph A is less or more?
Less.
Right. When we
Less.
see that, the frequency of a graph A, when we see that the frequency of a graph A is less than the frequency of a graph B, is less than the frequency of a graph B. Is less than the frequency of a graph B. Is less than the frequency of a graph B. So frequency less means what is less, Ra? Frequency is less means what is less? Pitch is less.
Pitch.
That's what. Hence, pitch of a sound shown by a graph A. Pitch of a sound shown by a graph A. Pitch of a sound shown by a graph A is less. Pitch of a sound shown by a graph A is less. Pitch of a sound shown by a graph A is less. So man's having what? Low pitch voice or high pitch voice? Man is having
Low pitch.
low pitch voice. That is you have to remember. Clear? Everybody?
Yes,
Low
sir.
pitch voice. So man's voice has low pitch. It means graph A shows man's voice. It means graph A shows man's voice. It means graph A shows man's voice. Clear, everybody?
Yes, sir.
Yes. Make it fast and answer the question. Everybody, I'm expecting everybody will answer. Definitely this weekend offline class, I'll check it and I'll ask you correct. I'll make it by the time. And remember, annual exams you have to face full of numericals only. No normal. Completed means let me know. Next question will go. Okay, next. Next question. This is you have to make the diagram also. Let me see who will make the diagram first.